I just want to take a second to talk about the state of technology today. Now, right now, I'm taking this class in computer science major, working towards advanced degree. I'm taking this class on system design, and I'm reading this stuff in this book. And this is like a high level class. This is, like final year kind of stuff. And it is so out of date. Like, it is so out of date, it's not funny. And while a lot of the principles of the class are good, they're sound principles about system design that I think really everybody should know, then that's most of it. But a lot of it is really obsolete. I have a couple issues with the material of the class. I have no problems with the teacher or the subject matter. Some of the materials here, not so good, and some of it is very out of date. A lot of this apparently goes back to I'm guessing the 1960s, at probably the earliest, maybe 80s, 90s, but some of these ideas and principles go way back in time. For example, right now, I am learning about setting up physical tables and data tables and file organization, and it's talking about fast data retrieval and about efficient use of storage space and how to set up these tables in ways to maximize the data retrieval and the amount of storage space used. And the thing is the amount of effort that you would have to put into designing these tables this way, it will end up costing you more as a business in the long run to pay somebody to set this stuff up this way than it would be to go out and buy better hardware that would produce at least the same, if not better, results than paying some computer scientist like me to do this stuff. Now, I'm not saying that that computer scientists are useless. Who are very useful people, but this is not what we should be spending our time on. It's a waste of effort. It's a waste of money. And I know there's a lot of older purists out there that would disagree with me. And yes, it'd be wonderful if we, could fit the Library of Congress on a USB drive. That would be wonderful. But really, that's not really our goal here, is it? We're talking about, setting up business databases, right? And so, I don't care how big of a business you are. Like, I don't care if you're Google or Amazon or IBM or Microsoft. You're not going to need to waste your time on this stuff. People don't understand where we are at with technology today. And this is really what I want to talk about here. I want to talk about where we are today in technology, okay? It's 2011, it's almost 2012, okay? And, think about what we have today in technology and compare it to 2001. Okay, let's compare it to 2001, and let's look at where our technology was back in 2001. In 2001, I was still using a dial-up internet. All right, I had a Pentium 1 computer. I don't think it was even like a Pentium 1. It was like a Pentium CE or something like that. And it was like slightly less than a Pentium. And at the time, like that was like super high tech, 56K dial-up modem, ooh, blazing fast, and my near Pentium computer that I was able to use to like video editing and photo manipulation and surf the web and play video games and download MP3s and all this crazy stuff, right? And like, woo, wow, exciting new technology. But today, we literally have more technology than we know what to do with. Like, for example, my little crappy laptop that I bought at Office Max. It's a Intel dual core processor, right? So it basically has two CPUs in it. One half of my CPU is 4 times as powerful as my Intel computer was back in 2001. I've got more than 20 times the amount of physical memory in my machine than I did back then. You know, my hard drive in my laptop is half a terabyte. I've got a half a terabyte hard drive in this thing, and then I've got another 3 terabytes external hard drives that I just basically use for storage. I barely even use them. They're just like extra backup archival data. I can't even use the actual 500 megabytes or half a tera or 500 gigabytes of data, half a terabyte that I have in my laptop. Like, I have not filled it up yet, and if I were to fill it up, most of that would be useless archive storage, videos and music files and stuff like that. Stuff that I'm not actually using all the time, just like random storage. There's really no way that I could fill up half a terabyte of information that I'm actually using on a personal computer level. I mean, you can go out and buy a terabyte hard drive from a regular retail store for like $80. I mean, that's insane how cheap that is. And really, we're probably paying too much for it. I'm sure if we were buying it wholesale, it'd probably be like maybe for like $30, $40 for a terabyte. Like, honestly, like, what business in the world is going to pay some computer scientist to go through all this trouble to try to maximize their data retrieval system, going in and nitpicking and tweaking every bit and byte in the system to make sure that there's, no unnecessary unused space on a hard drive. Like, that doesn't even make sense. Like, why would you do that? For what it would cost you to buy the hardware that would outperform what would take me months of work to do to try and figure out with my dinky little human brain, right, how to maximize this for like highest data retrieval I/O efficiency. It would cost 2,000 times what it would cost you just to go out and buy some new equipment. It doesn't make any sense. It's completely ridiculous. And I want you to think about this. This is really the key. This is really what I want people to understand out there. Is, I talk about my laptop being a dual core system, and we think, oh, fancy, it's got 2 cores. Wow, we're in the future, man. 2 cores is nothing. That's nothing. Okay. There's computers out there with 4 cores and 8 cores and 16 cores, right? And those are nothing. Those are nothing. Like, the most awesome, craziest computer that you can buy with money is nothing. It's nothing compared to what we can actually build today if we want to. What we have the physical ability to build and the technological understanding to build as far as computers go. Okay, so think about this processor, right? These multi-core processors. All right, I want you to think about a loaf of bread, okay? And think of a loaf of bread as a 3D object, okay? It's got height, width, depth. It's a 3D object, okay? Now, basically what we're doing with our processors today is we're taking that 3D loaf of bread and we're cutting it into slices, okay? We're cutting it into individual two-dimensional slices, okay? And then we're taking those two-dimensional slices and we're laying it out on a flat surface. Like we're laying it out on say a cookie sheet, right? And so we've got now, imagine you've got, let's start off with two. So let's say you've got two slices of bread on a cookie sheet, right? And what we're doing is we're taking this little question or piece of data that we want to manipulate, and we're sending it through slice of bread A, okay? And at the exact same time, we've got information B, question B, whatever, however you want to put it, process B, and we're pushing it through slice 2, all right? And when it comes out the other side, we've got a piece of information C and D, okay? And so now what we're doing is we've, instead of going through one slice of bread, we're now going through two slices of bread, right? And so we're getting two things done at the same time, but we're still doing it the same way we were doing it back in the 1960s, when we used to have those big mainframe computers that ran on punch cards that were only at the college universities and certain, rich high schools, okay? We're doing the exact same thing we were doing back then in the 1960s, except for now we're doing it on multiple slices of bread, okay? And now imagine you've got, an 8-core processor, so now you've got 8 slices of bread on your cookie sheet, right? And you've got 8 slices of bread on your cookie sheet, and you've got your 8 questions or your 8 pieces of data, and you're pushing it through simultaneously, and you're getting 8 pieces of data coming out the other side, right? And wow, that's like super fast. That's like having 8 computers in one, right? And that's exactly what it is. It's like having 8 regular two-dimensional computers in one box, okay? And wow, that's super fast. Very few people have 8-core computers because nobody really has a need for 8-core computers. Nobody really needs to push that much data. Unless you're, DreamWorks working on the latest, Toy Story movie, or, Shrek the 18th, you don't really need an 8-core computer. There's no use for it. No business would really even use it. Unless, I guess, maybe if you're Amazon or Google and you've got these giant servers that you need to run, maybe then, possibly, you might have 8-core computers that you're running. Most likely they don't. They probably have quad core, 4 cores, I would bet. I don't know. I'd have to ask them. But this is my point, though, is we're still using slices of bread, okay? But we can, if we wanted to, we could build the whole loaf. We could run the whole loaf of bread. We could run 3-dimensional processing, which is it's kind of in between phase between what we're doing as computer processing and quantum mechanics computing, which is where we want to go. That's when we have quantum mechanics computing. That's when we can have stuff like teleporters, and we can just teleport ourselves across the planet if we want to. But before we can get there, we really should build these 3-dimensional computers. We should build these whole loaf of bread computers. And the reason why we don't, because we can do it right now today if we wanted to. But the reason why we don't do it is because we wouldn't know what to do with a 3-dimensional processor. Our tiny human brains cannot think of a reason to run a 3-dimensional processor. We wouldn't know what to tell it to do. The human logic does not exist, okay? Because you have to understand that what it comes down to is philosophy, okay? And we don't have the philosophy to ask the question for the computer to answer. Okay, it's almost like the Hitchhiker's Guide to the Galaxy. We got the ultimate answer. Now we don't know what the ultimate question is. So, yeah, with these slices of bread, basically what we're doing is we're pushing through what's called Boolean logical data. Okay, and so Boolean logical data is yes, no, and, or, neither, nor, equivalent to, equal to, not equal to. Basically, it ends up answering in a yes or a no. That's Boolean data, and some French guy named Boolean came up with it, I think 350 years ago or something like that. Okay? Mentally, we are operating 350 years in the past. Okay? Our computers are way ahead of the future, but our brains are way in the past. Okay? And so, what we need to do in order to advance the technology at this point is we need to come up with the new philosophy. We need to come up with that three-dimensional philosophy. Because what it is when you have a two-dimensional chip, which is basically, think of the piece of bread, and then each one of those, each one of the crumbs on the piece of bread is a bit of binary data. Either there's a little bit of bread there, or there's a little air hole, or a little air bubble where the yeast formed, And so either there's information there or there isn't. And so when you send this information into the chip, what happens is it needs to ask itself, true or false, which way does it go? Does it go left or does it go right? And then that's basically what a CPU is. It sends it in and says, okay, do I go left or do I go right? But now, and eventually, it all goes forward to the other side, which is, part of the process. But it's the path that it takes to get there. Does it go left? Does it go right? It kind of zigzags across the chip, right? But when we have three-dimensional processors, it's not just a question of yes or no. It's not just left or right. Because you could go left, or you could go right, or you could go up, or you could go down. Well, what the hell is up and down? We have no idea. We have no idea what the hell that is. We have no idea what that does. We haven't thought of it. I mean, people talk about, the turning point where computers become smarter than people. And we really are. We're really there. We're at that point. But the problem is we don't know how to get the computers to start thinking. They're physically able to outsmart us. A computer could physically outsmart us at this point. But we don't understand the philosophy to teach it how to think. And that's where we are technologically today. But if you think that's not going to happen, and if you think that's not going to happen soon, I'm telling you, it's going to happen soon. Because, time is ticking forward. The technology is going to advance. They're going to continue to make these more advanced computers. And eventually somebody's going to have to figure out what to do with them. Or else they're just going to stop making computers. And they're not going to stop making computers because we know how to make them. Why wouldn't we make them? It's just right now it's a question of trying to figure out how to make them cheaper. But we're coming there. We're coming to that point where we're going to soon have these computers. So we got to figure out philosophically, what we're going to do with it. And I'm not talking about Plato, what's the meaning of life. I'm talking about logic. I'm talking about we got to move past Boolean logic if we're going to take advantage of these new computers. And so that really is, I think, where we need to start moving in the scientific community, is trying to figure out what to do with these computers and what is beyond Boolean logic. That's really what we need to figure out. That's the next step in evolution. And it is going to happen. And I guarantee you that 10 years from now, we're going to look back today at 2011, 2012, and we're going to look at ourselves and we're going to go, oh my God, we were such stupid cavemen thumping clubs on the ground and rubbing sticks together trying to make fire. Like, that's how we're going to look at ourselves. We're going to look at ourselves as, like, not even understanding how a wheel and an axle works. Like, we really will look like complete and utter cavemen in comparison to where we're going to be 10 years from now. And I'm looking forward to it. And I'll see you there. I'll see you in the future.